The next step would be now to identify the other components. And if we look down here, we also have losses in the core. And the core losses are made up of two parts. So the core losses, also known as iron losses, are made up of hysteresis losses and eddy current losses. And these are true losses. So in a similar way, like we had copper losses here for the series components, we also have true losses. And these are true power losses. And they have units of watts. So in order to represent these losses, we also need another component. The only component that actually would cause losses is a resistor. But in this case, the resistor actually, or the core losses resistor, will be shunt rather than series, because this would depend on the applied voltage. So here we would actually add a resistor, and we would refer to this resistor as R sub C. So in order to represent these losses, we represent them using a shunt resistor. And the word shunt means that that resistor actually is in parallel rather than series. So here we had series components, now we have parallel components. The losses in series components would be proportional to the current. The losses in the shunt components or parallel components would be proportional to the applied voltage. So we use the shunt resistor and we've referred to it as R subscript C, and the subscript C refers to the core, or stands for the core. And we've placed this in parallel. So these losses, this loss is proportional. Now this loss is actually proportional to two components. It's proportional to the applied voltage, but it's also proportional to the frequency. So we know actually that eddy current losses increase with frequency and hysteresis losses increase with frequency. Generally, we will assume that the voltage and frequency are constant, and that will allow us to make the assumption that the core losses are constant. Now the other component that we need to place here is actually we need to represent the magnetizing current. And the magnetizing current, what people have found during the tests is that the magnetizing current is a current that is 90 degrees lagging the applied voltage. And if we think the only component that could actually cause a current to be lagging the voltage by 90 degrees is an inductor as well. So we use an inductor to represent the magnetizing current. And we refer to this as M, which stands subscript M for magnetizing. So just to take RC from there, or represents the core loss. And then XM represents the magnetizing current. And so the magnetizing current would actually flow in Xm, and we refer to the magnetizing current as I subscript capital M. And so now we've actually completed part of the model, but the model is still not fully complete. We're still missing an important component at this point.